Integrated versus dedicated GPU. Intermediate level. Graphics architecture and performance. Introduction. Modern computers use two main types of GPUs. Integrated GPU, iGPU. Dedicated GPU, dGPU. Both perform graphics processing, but they differ in performance, memory usage, power consumption, use cases. At the intermediate level, understanding these GPUs means learning how each type works internally, how they affect system performance, when to use each type, how they interact with CPU and memory. What is an integrated GPU, iGPU? An integrated GPU is built directly into the CPU, or system on chip. In simple terms, iGPU equals GPU inside the CPU. Example concept. CPU plus GPU means combined in one chip. How iGPU works: shares system RAM, no separate VRAM, uses CPU resources, handles basic graphics tasks. Characteristics: lower performance, energy efficient, cost effective. Advantages: low power consumption, cheaper system cost, sufficient for everyday tasks. Limitations: limited performance uses. System RAM not suitable for heavy graphics workloads. What is a dedicated GPU? dGPU. A dedicated GPU is a separate hardware component, graphics card. In simple terms, dGPU equals standalone GPU with its own resources. Example concept. CPU plus separate GPU card means high-performance system. How dGPU works: has its own VRAM, operates independently from CPU, handles complex graphics and computations. Characteristics: high performance, more power consumption, requires cooling. Advantages: excellent graphics performance, dedicated memory, VRAM, ideal for gaming AI. Rendering limitations: expensive, consumes more power, generates more heat. Key difference: memory usage. iGPU means uses system RAM, dGPU means uses dedicated VRAM. iGPU means uses system RAM, dGPU means uses dedicated VRAM. Performance comparison. Feature: integrated GPU, dedicated GPU, performance, low, medium, high. Memory: shared RAM, dedicated VRAM. Power usage: low, high. Cost: low, high. Use case: basic tasks, gaming, AI, rendering. How they work in a system. Integrated GPU flow. CPU means iGPU, means uses RAM, means display output. Dedicated GPU flow. CPU means GPU, means VRAM, means processed, means display. Hybrid systems, best of both worlds. Many modern laptops use both GPUs. Example concept. Light tasks means iGPU. Heavy tasks means dGPU. How it works. System switches automatically, saves power when high performance not needed. Real-world example. Everyday use: iGPU. Web browsing, office applications, video playback. High performance use: dGPU. Gaming, video editing, 3D rendering, AI training. When to choose iGPU. Choose integrated GPU if budget is limited, battery life is important, tasks are basic. When to choose dGPU. Choose dedicated GPU if gaming or design work, video editing, AI ML tasks, high performance needs. Performance factors. GPU performance depends on number of cores, clock speed, memory bandwidth, VRAM size. Example concept. More resources means better graphics performance bottlenecks. Even with a strong GPU, weak CPU, low RAM, slow storage can limit performance. Example concept. Strong GPU plus weak system means limited performance. Advantages of integrated GPU: energy efficient, affordable, compact design, sufficient for daily tasks. Advantages of dedicated GPU: high performance, independent processing, better for heavy workloads. Limitations summary. Type limitation: iGPU, low performance, dGPU, high cost, and power concepts learned. 6 difference between iGPU and dGPU. 6 memory usage differences. 6 performance comparison. Real-world use cases. Simple definition. Integrated versus dedicated GPU. Integrated GPUs are built into the CPU and use shared memory, while dedicated GPUs are separate components with their own memory and higher performance. Final summary. Integrated and dedicated GPUs serve different purposes in a computer system. Integrated GPUs are efficient and cost-effective for everyday tasks, while dedicated GPUs provide powerful performance for gaming, graphics, and computational workloads. Modern systems often combine both to balance performance and efficiency. Understanding these differences helps in choosing the right system for gaming, development, AI, and general use.